All right, so good afternoon. Welcome. Welcome to this session on contextualizing time series data with graphs. It's going to be two of us, myself, Devang, and Henning. We are principal product managers at Microsoft. I am part of the Fabric customer advisory team, CAT team, if some of you know, may not know. And Henning, I'll let you introduce yourself.
Hi everyone, I hope you can hear me. Okay, good, cool. So as Devang already said, I'm Henning. I'm a principal product manager in the Kusto team. I'm going to use Kusto probably most of the time in this talk. And I'm responsible in our team for everything around security, from network to identity and other things. And I also cover parts of the engine, which is geospatial related operators and graph. That's what we're talking today. Back to you.
So yes, he's the guy who builds the graph. So you're going to get all the details, all the underlying insights of how that works. All right, so we're going to start with, first of all, we welcome feedback. So please scan the QR codes and be ready with your feedback. We'll flash it again at the end of the session as well. Now, let's start with the family. What do I mean by family? If some of you were at the keynote this morning, Itzhak announced about Fabric real-time analytics. That's the solution which is available in Fabric, which runs on Kusto engine. Some of you may also heard about another announcement, but I'll get to it in a bit. So it starts with Kusto. Kusto is the engine which was created at Microsoft 10 years ago. We celebrated our 10th anniversary just last week. This Kusto engine has been created at Microsoft to store logs coming from all the different cloud services products that we have out in the market. And very quickly, Kusto grew in popularity in Microsoft, and a lot of products started using it. Kusto engine is available in Fabric as Synapse Real-Time Analytics, KQL database. So this is if you go to Fabric, if you want to create a KQL database or event house, it all runs Kusto as an engine under the hood. It's also available in Azure as Azure Data Explorer. So that's the Azure version of Kusto engine that you can use if you're into Azure side of things. Kusto is available also as a Docker container. So if you want to deploy Kusto as a container on your local machine and play with it, interact with it, you can also do that with Kustainer. This is also available as a deployment option. But Kusto is also used by a lot of different solutions in Azure. So Azure Monitor, Log Analytics, they use Kusto under the engine in order to give you the interface to analyze logs. So that's one solution. Second solution is Sentinel, Defender, PlayFab. All these products at Microsoft are also using Kusto as an underlying engine to deliver their services and solutions to you. And this morning, you may have heard about a new announcement, which was made by our sister team, SQL Server. So SQL Database Watcher for Azure SQL is also using Kusto as the underlying engine. So this is how all the different solutions come together that are using Kusto as the underlying engine for delivering these services. Now, we love big data, and we don't only love big data, we really love really big data. So this is just to give you an idea how much data do we ingest in Kusto as a service globally. So 220 petabytes, as you can see, 3.25 billion queries that we run every day or serve every day. We're sitting on about 20 exabytes of data. But this is a static slide. So maybe we should look at, in real time, how much data are we really ingesting and how many queries are we really serving? So,
okay.
Yeah. So this is a real-time dash. Oh, sorry.
We're still in presentation mode.
And we should be okay now, almost. Yes.
Yes, no, maybe.
All right, so this is a real dashboard to show you how much data are we really ingesting in every day in Kusto. So it was 220 petabytes, actually 250 petabytes. It was through 3.25 billion queries, but it's actually 3.3 billion queries that we serve every day. But the interesting thing that I would like to bring your attention to is if you see, we serve about 3.3 billion queries every day, but out of that, about 20% or 25 million or 30 million queries are actually served by humans. So all of the queries are actually applications sending queries continuously to Kusto. So we serve both types of users. It's not just only human users. That's a small percentage, but a lot of app-to-app communication or app-to-app queries. So this is about Kusto. Now Kusto has a lot of capabilities. If you have been at the session yesterday that Frank and I delivered, we talked about multiple different ways or multiple different types of data that you can bring into Kusto. And today we are going to talk about graphs and what can you do with graphs and time series data in Kusto. And with that, Henning.
Thank you, Devang. Actually, we still have to put those slides of the size of Kusto because usually the crowd it doesn't really know enough about Kusto or Azure Data Explorer. That's why the reason is we put those slides. And also the slide of the family is very important because whatever I'm going to show you in the next couple of slides, it's applicable to all of the other products which have been developed on top of that. So whatever we add to the engine, you immediately have it, for example, in log analytics. Or you can extend the network watcher logs and contextualize them. What we found out in the last couple of years, actually, we're trying to position this since multiple years, is that time series data alone is nice. It's nice to have it. So you have a timestamp, a tag ID, and a value. But you need to put this kind of time series data into context. For example, if you look at an operational plant, a production plant, a lot of time series is being produced, and you want to monitor a specific asset, you need to know where that asset is connected to. And sometimes customers are doing that using a simple join, but that's just a flat contextualization of data. When it gets more complex, you end up having a hierarchy and at some point even a real graph. And that's what we try to do. So just a brief introduction what a graph is, like really simplistic stuff. A graph consists of nodes and edges. So you have a set of nodes and edges connect nodes. You have properties on the edges and you have properties on the nodes. Now, we decided to add this to Kusto, but actually why do this? So reason being is, if a customer has, several terabytes or even petabytes of data in Azure Data Explorer and then wants to contextualize data, what they had to do in the past is have a different database on the side, and that might have been like a real graph database, and then whenever you wanted to combine data from the graph database and time series, you need to speak the language of the graph database, you need to speak the language of Kusto, then you need to be able to run the glue code between. And that's a lot of friction for developers. So we believe that if we bring some of the algorithms closer to where the data actually sits, it brings a lot of value to our customers. And that was the main motivation why we wanted to do this. As a consequence, if you don't have to create like many other databases on the side or maintain many other databases on the side, just reduce your overall spend, so your costs are decreasing. One very specific USP of Kusto and graphs is that Kusto naturally is a time series database. And that's also the same way that we look at graphs. It's just a collection of events. A node is being created, a property is added to a node, an edge is being created between two nodes. And Kusto can not only efficiently query the last known state of the graph, you can also go back in the past. This is extremely important for a lot of scenarios. Again, industrial IoT scenarios, when you want to calculate, for example, the operational efficiency of a production plant, you need to do this with the graph at the exact point in time that you want to calculate this operational efficiency. Otherwise, it might be a totally wrong calculation. Last but not least, our users really love KQL. I'm going to show it later to you. I hope you have seen it before because I'm not going to start with the easy part. With KQL, you get IntelliSense, and all of these nice features are also applicable to our Kusto graph extensions. So what's the current state? If you're dealing with such a big project of trying to add a new engine to an existing engine, you do it in several phases. And we decided to do it the easy way first. So we start with the tabular expressions. A tabular expression can be just you're querying a table or you're querying some other table, you project, extend, do whatever. So that's a tabular expression. And an absolute must, because otherwise it would be pretty boring, is to have a list of edges. In graph stuff, you call this adjacency list. So a list which identifies that one node is connected to another node. Without that, it's pretty boring to create graphs. Optionally, you can also have a tabular expression for nodes to augment properties on the nodes of the graph. Now we take this we execute a statement which is called make graph, which defines the relation between source and destination in the graph. And when you create that, we create two in-memory objects. One is the graph object, which is literally just an in-memory representation where you have a number of nodes. The nodes have on their objects, they have edges, and it's a direct pointer to the other node. So it's beneficially for the classic benefit of graph databases of having an index-free adjacency. So this kind of graph can grow much, much larger, but the time to traverse from one node to the next node is constant, which is great for doing efficient calculations on top of the graph. As a second object, we also create the well-known Kusto in-memory column store. That helps us to reuse all of the Scala operators that we built over the years. So you will see it later. Now, once we created that object, you can run other expressions on it, other operators. One of the most used one is the graph match operator, which looks like a little bit a mix between KQL and Cypher. You will see it later. Now that's the current state. The feature is still in preview. It's in public preview. We started the private preview in December 2020. Since then, hundreds of users, thousands of clusters have been using it, so it's really mature, and we are making really great progress. But the initial release consists of 4 operators. First operator is make graph, so create the graph object. Second one is graph match, find paths in the graph. The next one is graph merge. It's kind of divide and conquer. So you create smaller graphs, and then you merge them into one bigger graph. It's just syntactically, sometimes it's nicer. And then graph to table is you created a graph, and you want to have a tabular expression of that graph, sometimes useful for visualizations. The graph engine that we implemented follows the property graph model. It's completely in memory. Also, the properties are in our column store. And it's a query time only construct, which means we create the graph in every query. This has funny side effects. Definitely the non-goals, we're not going to go into anything like distributed graphs. We have the feeling that other real graph vendors invested a lot and didn't come to like a perfect solution, so we don't even aspire doing that. So we want to stay at the moment with small graphs that fit on a single node, but they are absolutely trimmed for performance. No, positioning is we will not become a graph database, okay? That's why we explicitly said we want to do graph semantics. We added graph semantics to Kusto in the engine. We don't aspire to be the next, I don't know, Neo4j, Tiger Graph or something like that. That's not our goal. The main reason is the second one. We have a lot of beautiful, we call them customers, or customers, okay, with a K. We are very creative when it comes to names. And we just want to make them happy. That's our only mission that we have. And we had active asks from customers, questions on that. So before I go and kick off some Kusto queries, any questions so far? Can ask them now or also later? None? Okay. Don't be shy.
Has anyone tried Kusto Graph?
Okay, very good. You, Aviv, okay, I count on you. Very nice. Okay, I prepared a couple of demonstrations for you. Don't be afraid. I mean, it might be a little bit rough, but it's all going to be fine. What you see here, so who in the room has seen KQL before? Okay, most of the people. Okay, so, and you have used it, I guess, mostly through log analytics and stuff, Azure Monitor? Okay. So I hope you can see it. So what you see here is just two data tables. It's just a query time construct for creating tables because I was too lazy to create and persist them. And it's also easy for demonstrations. So I have one list of employees. They just have a name. So Henning, Avner, Uri, Odette, and Yitzhak. And then I have this adjacency list, just call it reports from employee to manager, where I'm reporting to Avner, Avner reports to Uri, Uri reports to Odette, and so on and so forth. So if I execute it, and I hope, the first time that I'm executing it on a KQL database, the database needs to wake up. That's why it takes a little bit longer. Now, in order to use the graph operators, it's very simple. You just use make graph, and then it's like literally very easy. You just say employee is connected to manager. And now you're like almost done, okay? If you want to additionally augment the nodes, so nodes with properties, you don't have to do it, but sometimes it makes sense. I will show you later on why. You just follow the IntelliSense with, oops, let's say employees on name. Didn't have to do anything, so I just used the IntelliSense. Now I have a graph object essentially. Now I want to show later on some visualization stuff, but let's just do some small query. Now I want to do a graph match, so I want to create a path. So I start with typing graph match. Then IntelliSense immediately allows me to pick a certain pattern. I'm going to pick this pattern. I'm going to explain what that actually means. So everything that's, for example, N1 here is a node. You can identify this by the parenthesis. And then in those brackets, you have the edge. This is a very special edge. You know, people who know how to read Cypher might immediately see what that means, but I explain it to you. It means that there's a connection between N1 and N2 that we are searching for. There's at least one traversal that I need to do, but it can also be 3 traversals. So it's something like a recursive join definition. Okay, previously with traditional join operators in Kusto, that would not have been possible. So because sometimes you don't know if it's like 2 hops away, 5 hops away, or 100 hops away. So you need to have that kind of capability. That was the main deliverable in our current version. And then I have another node. It's N2. Now I created them, and now this is called a pattern. Now once I created a pattern, I can create constraints, and you see you immediately get using the IntelliSense, I get the variables. So I want to say N1 dot. See again, IntelliSense name equals Henning, and then I can say and N2 dot name equals let's say Odette. Okay, now I defined actually the path. I want to have the path from Henning to Odette. Well, okay, I get now as a result a couple of paths, at least internally. Now I need to project it back to the tabular expression. The way to do this is just use project in here. And I say, okay, let's do Henning. So Henning equals N1 dot name. And I want to have the path to Odette. So I say path equals, and now I'm using the edge, okay, and will return an array. Edge, and I say, okay, let's use, sorry, I was jumping. Let's use the manager. Now if I execute this, it's going to send the tabular expression to Kusto. It's going to create the graph, then it calculates the graph match, and the output is, okay, it really found me, it's Henning, and then the path is going from Avner, Uri to Odette. So there's a lot more with those graph match statements that you can do. So for example, you can define if you want to have cycles, if you want to allow cycles in the path, if you want to allow cycles based on nodes or only avoid cycles based on having an edge traversal twice, all kinds of tweaks, but we're not going to go into that. Before we actually continue with all of the time series stuff, I want to show you something else that's really useful. You know, in Kusto, you might have seen it throughout the sessions. You can create tables, of course, and then you can create derived tables and connect them with an update policy. So you have like a graph relation. Then the data, sometimes also people call it the silver layer. You want to create the gold layer, so you create the materialized view on top of that for doing deduplication. On top of that materialized view, you create a downsampling materialized view. And then at the end of the day, you also want to export something to a lake. Okay, very complex. And in order to understand this, it's a graph. So you need to have a nice lineage view. So Alex, our head of engineering, thought it's not a bad idea. Let's do it directly in Kusto. Entity. Okay, I created a small, rather complex database environment here, and let's just try and see if it works. So you right-click on a database. It's here called entity graph, and then you click on .show entities graph, and the only thing that it's doing, it's running a command. it's creating a graph, and boom, you have your graph. It's not nice, you know, we are not well known for graph visualization or visualizations in general. But as a data engineer, it's a good start. And I can even improve it, okay? I can say, instead of clustering layout, I would like to have a group layout. Now, the nodes, labels of the entity makes a lot of sense. But let's color them based on the entity type. The edges, they should also have, let's say, the kind, and also the color should be a kind in here. So what you see here is, let's start with the basics. Zoom. I have an external table here, so that's sensor data, that's a function. Okay, here, that's the data where, that's the table where we land the data. Then we're using an update function, which is this function, to propagate data to this table. From this table, we build a function on top of that table, and guess what? That function is used by a different function. And this is incredibly helpful if you want to find out about dependencies between functions. At a certain size, this is really useful. And then, of course, from that table sensor data, we have a materialized view, which is deduplicating. And on top of that, there's one who's doing downsampling. This is an external table. And for an administrator that is using Kusto, just that simple functionality provides a lot of value. But now let's add a little bit more on the time series stuff. So now it's getting a little bit, let's say, deeper, and you know, it is what it is. Kusto, since the beginning, has been used for logs. That was our main job in the beginning. And what you see here is another data table with a raw log. It's just a simple string. And SQL guys were partying a lot this morning about regular expressions. Let me just show you something. So those kinds of raw logs, let's just send them here. They look like this. It's just a string. Okay? So if you want to get an understanding of what's happening in that string, you can parse it essentially. And what we're doing here is I'm taking the raw logs, I'm using the parse function and just define the pattern. So IP address, then something else comes, then it's a timestamp, by the way, it's a datetime, an HTTP verb, and a resource. And at the end of the day, you get those parse logs really easily. Let's just have a look at the parse logs. Okay, so I know if the IP address, the timestamp, the HTTP verb, and the resource, like super, no pain. Very, very helpful. So now I have my edge list essentially. The edges would be IP address to resource, I guess. Then the nodes I create from the edges, so don't worry what this little friend is doing. Then I'm taking the edges, and the adjacency list for edges. I'm connecting the IP address to the resource, augment the nodes, and then what I'm doing here is, it's a shopping basket recommendation. So you call it a co-occurrence analysis in graph theory. So what's saying here is the start IP is doing a request to a resource, and another IP is doing another request to another resource. And then I want to find out, I want to give a recommendation, essentially, like what are other resources that are being used. So I start at IP addresses, create the constraints over here, and then you find also already the first like time-based query in here. The first request should not be more far away than 5 minutes from the second request. So you just say the initial request minus the other request should be smaller than 5 minutes. So we filter on the recommendations based on the last 5 minutes. So if I'm sending that, I get a recommendation back on product 42. Okay, super simple. As you might not know, you get also a lot of information, additional information from Kusto on what actually happened. So if you want to go and take a look at the details, you find two more information sections. One is on the make graph. You see that it took, I don't know, 0 time to create the nodes, 0 time to create the edges. And there were actually 3 edges and 4 nodes involved. That's helpful if you want to debug what's actually going on. Now, let's go and, let's say, shift gears and look at an industrial IoT scenario. I'm going to give a rough explanation. It has a lot of details in it. But just think about the scenario where you're actually trying to find, you have a production plant, and it consists of a lot of assets. Now what you're trying to do is, you're trying to find sensors in your production plant which have anomalies in their time series. Now, from that anomaly, once you detected that anomaly, you want to calculate the blast radius. So what's going to happen if that anomaly is failing? So in this example, it could be a pump that has a pressure sensor. Pressure sensor is showing increased amount of anomalies. Now you want to know what all other things are connected to that pump. Okay, if you would have to do that in some other system, you would need to first probably calculate the time series, then you find your anomalies. Then you need to take the data out of those anomalies, query the graph, and then get the events eventually. You can do that, it's no problem, but it's now in a single statement. So here we are calculating the assets that have anomalies. Don't need to talk about make series and all of the series fill that we're doing, that's not that important. And then we're creating the graph and we say we want to go from an asset, at least 1 hop or maybe 10 hops, because we don't know, to the production line and eventually end up at the factory. We get back some result and then we just want to do a regular summarization by the impact on the factory. We execute it, and we see, of course, everything is like just canned data. Factory 1 is impacted and production line is impacted by some measurement, okay? It's just to show how it works. So what you've seen here is we combine time series analysis. We combine as well anomaly detection and graph in a single statement. And one thing that I also forgot, might show it later as well, is we created a graph at a specific point in time, but I think I have a better example later. Just maybe like one more example from that domain, and then I just stop it and maybe only 1 or 2 more examples. We have been actually funded internally by our security team. I mean, no, that's a bit of a no-brainer. All of our data at Microsoft, when it's security related, is stored in Kusto. And attackers are thinking in graphs. And as long, John Lambert said that, so I just repeat what he's saying. And as long as attackers are thinking in graphs, they're 1 step ahead of the defenders who are thinking in lists. Now, this is a classic case where I think it's called the Bloodhound scenario. And in that Bloodhound scenario, customers tend to use Neo4j. That's the statement that they are using. And I just translated this statement into Kusto with the same data set. And here I'm using also one example. Oh, it should be in the next one, but okay, I can also explain it here. So, sorry. So what I'm doing here is I'm actually using tables that are stored on OneLake. You don't necessarily have to store the tabular expression directly in Kusto. They can also be somewhere else, like in OneLake. So I'm getting here the external table called cybersecurity edges. And what I'm doing here is I'm calculating on the same in-memory object. I calculate if a user has direct access via RDP or if a user is a member of a group that can RDP into a computer. If you would like to express all of that in a join, good luck, you can do it. But then readability goes south. And this is something that you can explain. It's whiteboard friendly. It's powerful. So that's why, it's been used widely. Actually, that's what I wanted to show. So just to wrap up, even as a system administrator who's just administrating the Kusto cluster, you can use it in order to get some sort of a lineage graph. That lineage graph will also be embedded in other experiences, by the way. It will come in Fabric. It will come in other experiences in our Azure portal. It will come. But you can have it in Kusto Explorer now, today. You've seen like really, really basic visualizations. We are also going to bring them to our web appearances like Kusto Web Explorer. They will also be available in the dashboards eventually. So we're working on that. So it's part of our next semester. You also have seen how to create graphs at a specific point in time and combine all of these time series operations. Now,
shall we take some questions just in case? Any questions so far? Yes.
Hi. So I have a question on the example with the hierarchy of the employees.
This one? Of the employees?
No, the where your names. Yeah, this one. So in this graph match, you have, if I understood it right, you have a hierarchy level of 3, right?
Yeah, up to 3.
Up to 3, exactly. What would you do if you don't know how deep the hierarchy is? So
how deep the hierarchy is, you need to make a guesstimate. You know, some databases, they cap it to a certain limit.
Yeah.
For example, there are some out there, don't want to call names, they say you can't do more than 3 hops, which is pretty poor. Others limit to, I don't know, 20 or something else. We initially had a limit on 16, but I said why. So we're just going to have, we don't have any limit here. So we can also be 100 or 1,000. What might happen in very dense graphs, that the complexity, number of paths that you're creating will just explode in memory. But then you need to fix it in your query. There's nothing, not much that we can do here.
But is the 1 to 3 is the number of the paths or is the number of the hierarchy?
No, the number of hops. So yeah, I'm like Avner is my manager. Avner reports to Uri. Uri reports to Odette. And the hop from me to Avner is counted as 1, and then from bam, 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 and so on and so forth.
Understood. Thank you.
Welcome. Thank you for the question.
Any more questions? Yes.
So as a Mac user, Kusto Explorer is not available for Mac?
It's not available. We are not going to do it.
Azure Data Studio, when will I get this here? Since that is for Mac.
I think we deprecate it. No, I don't know. So, okay. You know, just 5 minutes before the session, I was talking to the dev managers and told them, listen, we need to make the bubbles a little bit more blue and the edges 1 item thicker. And he said, okay, I'm going to create a quick build for you. You know, he's one of our founders. And he just did it. So we are using Kusto Explorer as a tool to get stuff out really, really fast. And other experiences, usually they take longer. And that's why I demonstrated it in Kusto Explorer. Our major goal is to bring everything that you can do in Kusto Explorer also to all of the other experiences. It's just faster for us. And I like fat clients, I'm sorry. Yeah. Other questions?
Any more questions?
Okay, so let's continue. Usually questions come up about Henning. Come on, are you serious? There's penalty for that. If you create a graph every time, like what's the point? And there's a massive overhead on it. I think I even created a dashboard for that. Let me just find it. Okay, here's the dashboard. So what you see here on the x-axis is the number of nodes and edges in the query. Like you've seen all of my examples, there's a number of nodes and a number of edges, and if you summarize them, you get a number, and we call it number of edges, okay? A number of nodes and edges. So you see on the x-axis, it goes up to 200 million nodes and edges, and on the y-axis, it's the time in milliseconds. You know, that scatter plot is not super nice because it doesn't really show the heat, like where most of the queries are. That's why it might be a little bit, like for the eye, not 100% correct. That's why I added the percentiles here to create the graph. And that includes reading the source table, creating the in-memory graph, and creating the in-memory column store. See and let's just start small. Let's say,
maybe Henning, you should add some context. This is the data from our own Kusto logs, in which you are scanning all the logs to see which graph operators are being used and your calculations.
Yeah, meanwhile, approximately a couple of trillion, I think 5 trillion graphs were created. 5 trillion graph elements were created. And you know, we are good at collecting all of these metrics. And we get statistics, and those statistics, those are real statistics from the preview that you see here. Okay, so it's not something that we did in like executing 5 queries. That's the data of the last, I think, 60 or 90 days. And if we, let's say, take medium graphs, you see that the 50th percentile is 0 milliseconds, and it starts going beyond like 100 milliseconds in the 95th percentile, okay? And the 99th percentile is a little bit more. But it shows that for medium-sized graphs, like 1 million nodes plus edges, it's absolutely fine to create in a memory for each and every query. You don't need to think about persistence. You don't need to do any complicated stuff. So we said it's quite okay. For smaller graphs, and by the way, 1 million is probably a big industrial IoT company. So that's not for industrial IoT, that's not small. 10K is even like ridiculous, right? It's instantaneous. If you go for 100 million, it adds some more latency, but 100 million, that's usually starting like Microsoft scale security cases, like real security scenarios that are huge. And then having some extra latency is just a penalty that we have to pay at the moment. So those are the numbers, and they're quite impressive. Okay, so let's talk about next steps. What are we planning next? It's very accurate slide. We want to GA it. GA means making it generally available for Microsoft, so that everybody also gets support for it. We're probably going to do that in April. Not on April 1st, and it would be an April Fool, but in April we're planning to do that, and just need to do some cleanup, and then we're going to release it. But this kind of like didn't hold other people at Microsoft back to create new reference architectures. And that's, I think to share, the slides will be shared. There's a reference architecture for manufacturing ontologies. There's a link on GitHub, it's all open source. There was previously, they used an Azure native service called Azure Digital Twins, and they realized that they can also use Kusto, so they reduced the number of services that they have in this architecture, which reduces the complexity. I mean, it's not a simple architecture, but industrial IoT, for who did it, it's never simple. But in this architecture, what you see is, or what you find is, that ADX or Kusto or real-time analytics is serving both the time series and the graph aspect of the scenario. Yeah, go for it and read it. Now, a couple of more infos. We have a graph overview documentation, graph operators documentation. You can follow Kusto graph and yeah, keep calm and provide context. If you're interested in a real-world scenario, how to get data from a digital twin in a CDC into Kusto and then work on those queries, I created a repository for that. It's also a link. And last but not least, you can also try to rescue Professor Smoke from crypto. Okay, it's a big mission. You play the Kusto Detective Agency for who played Kusto Detective Agency? Okay, all of the other ones need to play it. If you're searching for a fun way of learning a language, getting credly badges, then just go for it. You know, it's entirely for free. It's a game, and actually we released the public preview of graph semantics as part of a game. I think we are the first database who did this. And it's super fun to play.
And so it's not only about language, it's also about if you want to put your big data analytics skills at play or in use or in motion, then this is an amazing game to play. So it's not only about Kusto and language and everything, it's really applying your mind and using some analytical skills. So it's a lot of fun. It's just a disclaimer, it's very addictive as well. So.
Yeah, correct. So with that, I would say, first of all, open it up again for questions. And if you don't have any other questions, we still have 10 minutes for questions. Okay.
Yes. Aviv has questions.
How do you scale this stuff? Do you have something to tell me about it?
Yeah, so scaling this up is part of our roadmap. As I said, the first goal is to have it as an in-memory representation of the graphs, but later on we're going to create first-party objects of graphs in Kusto. It will be in the same level as tables, and later on we're also going to persist it. So we're going to have persistent graphs. What we're not trying to do is to shard the graphs and distribute the graphs over the, let's say, border of a single node. We don't try to solve that. However, we already working on an operator that is called the partition. So in a partition operator, you could run a partitioned make graph. Let's say you have a security scenario and you're an ISV and you're serving 100 clients and you want to find a specific attack path. Of course, you could iterate over the tenant IDs, and for each and every tenant ID, you could run a separate query and then calculate the attack path and be good with it. But you can also put all of that in a single query and say that you want to partition the graph by a specific tenant ID, and then the graph that we are creating, we create not a single graph, we create n graphs, where n is the number of tenants that you have as part of this query. It's not really distributed graphs, but it's let's say a poor man's version of having a sharded graph for specific tenants for ISVs. That's definitely the next thing that is happening. And then we get a lot of questions to add additional operators. Customers are asking for connected components to find, for example, if you have many similar alerts in your system and you're trying to find alerts that belong together, then the connected components is incredibly helpful. Also for some simple things like package tracking, connecting IDs with each other, distributed tracing, where you start with a specific trace ID and you want to find all traces that belong to a specific trace. And next thing that we're also going to do is shortest path. So there's a lot of nice, good things on the roadmap, but first priority is getting it out, and GAing it, and then we take the next steps. Thanks for the question.
Any more questions? How do you scale Kusto?
Okay, somebody likes to promote his session. So the question was how to scale Kusto. Kusto has some limits. We can only scale to 1,000 nodes. That's the limit of virtual machine scale sets, and beyond that, you probably need to create a second cluster. Aviv, I think tomorrow, right? Aviv and Devang are going to talk about the feature that cost us a lot of money, and it allows us to actually save our customers cost. It's a feature about autoscale and optimized autoscale. I don't want to steal your thunder, so I'm not going to talk more about it, but it's making it cost efficient to use Kusto even more.
So to promote all the different sessions, so if you're interested in learning more about real-time analytics and Kusto, etc., there are 4 more sessions tomorrow. If you want to play and if you want to see real-time analytics in action, I really recommend you guys to go to the, there is a booth just behind the Microsoft booth, the Aditis booth. There are 2 guys here I can see. They have created a very cool flight simulator game that shows you while you are flying, how that gets visualized on a Power BI report, and they use Fabric real-time analytics using Kusto under the hood. So if you want to see that in action, we really recommend you to go and play that game. We tried it, and it was a lot of fun. There are a few more sessions, or there is 1 more session on Saturday on real-time analytics. So if you don't happen to see those sessions, there are a few more tomorrow and 1 more on Saturday. And tomorrow's session on auto-scaling will be again going deeper into Kusto, how we use machine learning in Kusto in order to auto-scale the whole technology. So if you want to again go for a deep dive, there's a session tomorrow as well. Any last questions before we close? Please do not forget to give us feedback. Would be good to know what do you think about sessions so that we can further improve in the coming conferences. All right. Thank you very much.
Thank you.